when you have to find the random variable, when you think about the random variable, it can take on any value, right? It's a continuous random variable. It can take on any value. It can be very, very small. We denote very, very small by this lazy 8 symbol in math. You don't have to bother about this, you don't have to use it. So this is a very small number, very, very small number given by this negative lazy 8 symbol, infinity symbol, and a very, very large number, very, very large number. So when we are talking about numbers, any number in the world, and a continuous random variable can be any number in the world. So it can be a very, 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 very small number anywhere in the world. We write it as minus infinity, just the negative lazy 8 symbol. That means a very, very small number, and it can be a very, very large number. So all the numbers in the world is in between. So if I say this is a and z is less than a, they're actually talking about if this is the normal distribution, this is the random variable z-score. Remember, we have converted to the z-score, so this is 0. So if I say this is a, so this one is very, very small number, minus infinity, this is very, very large number, anywhere in between is a. So when I say z is less than a, we are talking about this probability. This is the shaded region, that is the area. Z is less than a. So when we talk about z is less than a, this is what it means. This means z is less than a. When I say z is greater than a, then I'm actually talking about this region. This region, this is greater than a. So this is greater than a, and this is less than a. This region is less than a. So they're symmetric. You see, since this is one and the same, if we say the whole thing is 100% or 1, and if this area is something, then this area is automatically going to be equal to 1 minus probability of z is less than a by that logic. So if this is what you have in the table, and if you want to know this area, you take the whole area 1, you remove this, and you get this area. That's the logic behind it, just geometry. This is the shaded region concept. That is how it is working. Similarly, if you're talking about a negative value, if you're talking about something negative, when you have this and this is 0, and what happens is that if you say it is less than minus a, so 0 behind 0 is minus a. So if it is less than minus a, it is this region. Now if this thing is probability of less than minus a, by symmetry, if there is an a here, it would exactly be the same, because this is bell shape, this is 0, mean mode median equal, this and this, they're exactly the same. So this would be greater than, so probability of z is greater than a. That's why we have this rule that when z is less than negative a is the same as z is greater than a. That's what I meant when I said by the law of symmetry. This is all that means. So this thing and this thing is the same. Now the final one, in between. So when we say something is in between, so we have this very small number, minus infinity, very large number, plus infinity. We don't have to bother about that. So the standard normal distribution, this is mean is 0. So suppose this is from a to b. So suppose this is a and this is b. So this is the region. This is the region we are looking for. Now can we think of this like this? Probability of z is less than a is this. Now probability of z is less than b is this. Now just by the concept of an area of a geometry, this is the larger area and this is the smaller area. So this is probability of z is less than b, and this is a smaller area obviously because a is behind this. So this is probability of z is less than a. Now if you remove the smaller area from the larger area, so won't this region be left, won't this be left, because from here if you remove this, only this thing would be removed. So that's why we can actually write it down as probability Z is less than B, the larger area, minus probability of Z is less than A, the smaller area. So these are all done by symmetry and the concept of geometry. So that's all it is happening.